Okay, so now let's look at a specific question in absolute values.
Okay, must I give you the question that I got?
Yeah, let's look at specifics.
Alright, I got the absolute value of y minus 4 is greater than or equal to a half.
Okay, now there's a long way and a short way to do this type of absolute value. Which do you prefer?
Short way.
Okay, I thought so. The long way would be to go back to those rules we had before. The short way would be to change the absolute values into brackets and square. Okay?
Okay, how would you know to do that? Can you do that with any absolute value?
Because it's an absolute value inequality. And the same would go for absolute value equations. So you just change the absolute value signs into a set of brackets and square. But remember to square both sides.
Okay.
Alright, now you're back to a normal quadratic inequality. Remember we did this before. We've also got that table method where you've got to get everything on the left hand side and a 0 on the other side, and then you factorize, you get the columns and whatever. You remember that whole technique of the table method?
Yeah.
We don't sound convincing. Do you remember we did this? Absolute quadratic inequalities.
Yeah, I remember this.
Okay, so this is exactly what you've got. Your absolute value inequality has now become a quadratic inequality.
Okay, alright, I see. So that y squared minus 8.
Are you happy with that?
Yeah.
Okay, and then we're going to multiply right through by 4, correct?
Yeah.
Is that correct?
Yeah.
Alright, so now we need to factorize. Do you still remember how to do this?
Okay, well.
Okay, I'm going to rush a little bit, Jason, because I don't want to run out of time with this session, so let me help you out there.
Okay, 4 and 1, and then you'll have. You could. Yeah, 9 and 7.
Okay, I'm not going to list the rest of the factors because I'm pretty sure we're going to find it within that set.
Yeah.
Okay, 4 times 7 is 28. 1 times 9 is 9. 28 and 9 is not going to give me 32. Alright, so let me then multiply the 4 and the 9 and the 1 and the 7. That's going to give me 36 and 7. That's not going to give me 32 either. So then I go to the 2. 2 multiplied by 7 is 14. 2 multiplied by 9 is 18. And 18 and 14 will give me 32.
32, yeah.
Okay, so there I've got the terms that I will need. So I've got 2x.
Yeah.
Y actually, sorry, it's not x, it's y. 2y and 2y, 9 and 7. And now we just need to sort out the signs.
Yeah.
We are looking for a minus 32, so we are looking for minus 14, minus 18. So both of them will be minuses. So we have 2y minus 9,
Yeah.
2y minus 7 bigger and equal to 0. Alright, happy with that?
Yep.
Okay, then we need to solve for y in each case. So we'll get for the first bracket y is equal to minus 9 over 2. And for the second one, y is, not minus, y is equal to 7 over 2. So that's equal to 4.5, and that's equal to 3.5. Alright? Still with me on that part?
Yeah. Yeah.
Right, so then we draw the table. Okay, and we'll have smallest one, 3.5 there, 4.5 there, smaller than, smaller than, smaller than, smaller than. You remember all these tricks?
Yeah. I remember this now, yeah.
Yeah. Just been a long time.
Yeah.
Alright. So now we choose a number smaller than 3.5. So let's just choose 0. It's easier. Let's just choose 0, which will give us a minus answer there, and a minus answer there, and a plus answer there. Very quickly. But do you understand what I've done?
Yeah.
Okay, and then that will be minus, and that one will be plus. And then if we have to use that exact same value, because we had bigger and equal, we'll be using the 3.5 and the 4.5 exactly as well. But that will give us a 0 there, and the 4.5 will give us a 0 there. So none of them are excluded. We can use both of them. So now, since we are looking for bigger and equal to 0, we are looking for the two pluses, which means that will be our answer. Right, x smaller and equal to 3.5, or x bigger than and equal to 4.5. Do you agree?
Yeah, I agree.
Alright, and that's it. That's the solution to that original absolute value inequality.
Sure, okay.
But now, I've gone through this exercise to revise you on the table method, because there's an even shorter way. Do you want to hear it?
Yes, please.
You say that y minus 4, and then you do this.
Yeah, that's what they show me in my
Clear enough?
books, but it's hard to understand that.
So you don't know what I've done?
No, I see. It's doing what you did anyway. You just, you're working out for the positive side and the negative side.
Well, I've just taken that thing, and I made it negative on the one side and a positive on the other side.
Yeah.
That's all I've done. Okay, so which means we're going to have two separate inequalities. We're going to take the minus 4 across to that side, and we're going to take the minus 4 across to the left-hand side. So let's do the step 1 first, taking it across to the right-hand side, which will then give us y is bigger and equal to 4 plus a half, which gives us y is bigger and equal to 4.5. Okay, which is exactly...
Yeah.
Oh, that should have been y. Sorry, that should not be x, it should be y. Okay, and that's the one answer there. And then the other one, if we take the minus 4 across to this side, we'll get y is smaller than equal to 4 minus a half, which gives us y is smaller than equal to 3.5.
3.5.
Which is exactly
That's what
that
we have there.
Alright, so you could now go the long way around and do the table method to be safe. Alright, or you could just simply remember that. So the one, what we did with the first trick, we changed the absolute value signs into brackets and we squared both sides, and then it became a quadratic inequality, or you just make two inequalities. So it depends whether you want to learn a new
I
trick
prefer the
in
second
absolute
one.
values. That's good, Jason, as long as you remember that you now have to remember another set of rules.